Okay. Okay. There we go. I want to be able to get my voice nice and good here. There shouldn't be anything coming out of the speakers, though. It's like it's picking up some ambient. I just nuke the desktop audio. That way there's hopefully nothing extra coming through. Alright. I got some bug fixes that I need to do here. I realized the game's running pretty good, but then when you get to around like 2,000 entities on the screen, the game starts to experience significant FPS slowdown. And one of the things I discovered is that even if you don't fire any knives at the very beginning of the game, for some reason, like, we can straight up run the game like with no enemies generating at all, and all of a sudden the size of his knife is 19. um, Even though we're not firing any knives. So if let's see, so like I know for a fact that at the beginning of the loop is knife is empty because I've written code to test this already, right? So like, oh, and I need to unpause my music. Um, at the beginning of the game, his knife is size 0, but like, let's say like 4 seconds into the game, or every 4 seconds, we print out the size of the is knife map. See, look, 0, 19. That's weird, right? So it took a while for me to dig through and figure out what the fuck is going on, but I finally did. So we're going to fix that now. There's a lot of code it's called during an update. We update a bunch of the different maps containing our different components. Background transform components, background animations, transform components, rotations, animations, collisions, generators, and knife cooldown. Whenever we access is knife, if we're accessing it with a ID that has not been assigned to the map yet, this will result in the map assigning a default value to that location. And so what's happening on the first frame is that after isKnife is size 0, we're accessing isKnife with various IDs. And we don't want to do that if possible. So as an example, if we take this, comment it out for the moment, and instead of accessing isKnife, if the entity type for an ID is a knife and it's marked, then we do all this other stuff. This way we actually avoid accessing isKnife entirely. Hopefully this doesn't have any detrimental effects. We're going to have to do something similar for a lot of these other instances where we're attempting to do stuff like that. So instead of using isKnife here, if it's a knife or a soul shard, we just check the entity type's ID. A similar problem is going to happen with a lot of the other maps. So anytime that we can avoid directly accessing a map for an ID that we haven't assigned to it yet, because realistically we only want to iterate over those maps and not directly access them inside of methods that might be an iteration. So like in handle transform, we're iterating over the transform map, and we would want to directly avoid accessing certain maps when we spawn a blood pixel. It's a particle. And we might be able to get this down to a switch statement, actually. We technically shouldn't have to check this. Hey, QBD. I'm actually listening to Burzum right now. Let's see. Okay, it looks like I've eliminated direct references to it, except for this right here. Um, so in this case, we would want to do entity type. I don't know neurotic fish. Tell me more. Fill the chats up for me. Nice. I'll have to check them out. Neurotic fish. Okay, his knife looks normal. You probably have a similar problem with a lot of the other maps, but oh right, we got to put the generator back in. I think everything in the Dancing Ferret catalog is terribly dated. What's Dancing Ferrets? That's another term I'm not familiar with. But the name neurotic fish sounds like something that would be in like the uh the Hot Topic catalog, like Zeromancer. All right, so around 5 minutes in, we should have enough things on the screen. Let me fix the generator rates. All right, every 4 seconds. And hopefully, if this works, we can jack up the number of entities that we render like really high. There was a item placed too high. I'm not sure who's on my headphones right now, but they sound pretty okay. It's not Burzum though. Like if you don't specify what the next song is, it'll just start making decisions on its own. Fucking YouTube Music. What's up? Well, technically they are coming in waves, just like very rapidly right now. All right, so we got a new power up, as you can see. Um, the end result of this power up is actually really pretty cool. And as you get more of them, the effect multiplies. So you have like an increasing shotgun effect. All right, so we're still only doing like 200, 300 entities or so. Full health. Yeah, we'll get there, man. There's going to be a lot of movement primitives, right? That I'm going to end up implementing so that like we can kind of randomly select movements and kind of like make it really custom like that. There's a little bit of hiccups, but I don't know exactly what that is. Oh yeah. This feels pretty good. We're handling 600, 700. Oh yeah. Shit's getting fire now. Whoa. All right, we're comfortably rendering 12, 1200. All soul shards just come to me now. All right, let's. Not much of a slowdown. We got up to like 3,000 there, and I didn't really feel a hiccup. Let's let's try that again with a much bigger blood pixel count. Like let's quadruple it and just see that everything holds together. Chinese Game Boy, no. A little slowdown. But it feels much faster in general. There's some slowdown. Whoa. Look at that. That's pretty fun. Yeah, check the slowdown out. Oh man. There's definitely another bottleneck that I have to hit. Yeah, this is very bad slowdown. having to do all this. Well, that's not even right. I think I have an idea. I'm thinking we could create a completely separate type to manage the blood pixels, because there's so many and it's very expensive to iterate through all of the entities on the screen and manually decrement a lifetime counter for them like we're doing right here. So if we have, you know, 1,000 blood pixels per explosion, right? Like, I'd be willing to bet just commenting this out would allow us to spawn even more, because we're doing like one less memory access, we're doing one less management, and it's one less part of the Boolean to check to see if we need to do stuff. But of course, the more entities that we have on screen, the more items that we have to transform. So it would be like extremely convenient. Oh man, but see, then we have we still have a problem of associating each pixel with it. Fuck, this is a hard problem to think about. Well, right, that's essentially what we're trying to develop, is a particle system from scratch. In fact, this pattern is very similar to Lazy Foo's approach. Realistically speaking, even if we're dealing with like actual pixels, which in this case we can actually specify how large each one is. In this case, we're making them, let's see. I think at the moment they're 4x4, yeah. See, this is actually the approach that I was taking, and it's very similar. The only difference is that this is more of an object-oriented approach. Every particle has a x and y and a velocity x and y. And in this case, they're randomly selecting a color to generate. And they're actually tracking the number of frames per particle. So it's very similar to how I'm currently doing it. There's not really that much of a difference. In fact, they continuously kill and respawn particles in a similar fashion. A lot of this code is not too different. In fact, I've done this object-oriented style as well as the way that I'm doing currently, and there's really not much of a difference. we're attempting to optimize for being able to move large numbers of particles all at one time. And actually, handle transform might be the culprit. There might be other things too. Because if there's anything that ends up iterating over the list of entities, and we have like 1,000 or whatever on screen, and we end up doing that once per frame. See, it's probably the modulus. Modulus would be a slow operation. So update animations goes through every sprite and every blood particle has a sprite. Naturally, every particle has a position on screen, right? So attempting to turn off where are we not using that? On update 182. Naturally, okay. We can even get rid of this. Well, now you gotta have a separate system for every, Yeah, I mean, you could technically, like, render a separate texture or something just to handle groups of blood pixels. That could be an optimization that we explore in the future. That might be actually worth looking at. I see what you're saying there. This is a different way of phrasing it. Oh, this... Wait. Which entity types? Oh, wait. We have a completely separate check for magnetism. And actually, we should do... handle magnetism at the same time. Yeah, see, if I get a bit of a slowdown, because but it thins out, and on average, it's doing okay, but there is a noticeable kind of a hiccup. But update rotations is rotating. Okay. It's the only thing that is rotating. Update generators. What is generator? Yep. Yeah, see, none of these should actually trigger anymore, so I can comment this out. Hey Raj, this is Ubuntu. Yeah, no, I've thought about doing like hard entity management, like based off a number of entities on screen. Like towards the end of the, you know, I guess you could call it the end of the run through when you start getting like tons and tons of items on screen. I definitely plan on limiting the number of items that are on the screen, just because it makes sense to have a realistic cap on how many of certain ones you can collect and things of that nature. And there's going to be better like power up like spawn management, so I can turn on and off which power ups spawn for testing purposes, right? But one of the things that I want to do too is be able to print out how long certain methods actually take to run, or certain functions. and actually be able to do performance testing that way as well. The source is on GitHub, Raj, but in order to actually play the game, you're going to need the assets, which at the moment I do not have available for download for anyone. In many cases, you can ask me nicely and I'll give you the assets. Reach out to me on Twitter if you'd like that. But at some point in the future, we'll find a way to distribute the game in a better manner. But it's still super early. I do appreciate you asking, though. Update transform components. Handle transform. So something to consider here. Having to do all this requires an additional access, like an additional memory access, right? Since we already have the values that we need here, I mean, I thought it was cute to be able to wrap things up in clean code, but I don't think we can declare variables in here like this without doing this. But instead of doing transforms of id.x, we just do transform.x, transform.y. Yeah, you're probably right there too. Better yet, we can jack the config up to 4,000 right away. Oh yeah, it's definitely choking. Yeah, we need to find a way to move that into a easier to access location. If the compiler's not smart enough to optimize, or it has to grab it from some location. Let's see. Yeah, we currently don't have a global variable for that. No, we don't want to. No, we're avoiding multi-threading. Everything has to be run on one core because we're making a game in an old style way. It would be kind of cheating to try and start doing things in a multi-threaded manner, and at the same time, future games might end up being done multi-threaded, but for right now, this is a single core game. We don't want to cheat the computation by utilizing multiple cores. We want to have things really fast, if possible. So, one thing that we could do, because we used to have a window width. Man, this needs some serious cleaning up. Oh, it's not always going to be window width, but and it's not always going to be window height. That's choking a bit. That's definitely the theme. Like if we were going for a design theme, that would be it. Every day is motherfucking Halloween, bitch. It would make sense that at like a certain number of entities that we would experience a slowdown because of cache limitations. I believe this is the case. Even if we were to optimize certain things, there will be a fundamental limit to how many things will be able to comfortably move around at 60 FPS on a single core, right? Logically, that makes sense. So, in order to make the illusion of more things moving around, we'll have to come up with different tricks and things to find ways around this. Like having a limit to the number of blood pixels that we actually have on screen. Um, like, for instance, how could we like try to hack something in to handle that, right? So if we call spawn blood pixels. Oh yeah, well each one of them has their own uh, completely randomized velocity. So they're all moving at different speeds and in different directions. And they do overlap naturally. It's a raw 1-to-1 between what we set in the game JSON and how many actually spawn. No, I think even better than randomly removing them, although that is a good idea, is to set a hard limit on how many I can actually spawn. So right away, if we have too many blood pixels, don't bother spawning anymore. If entity size greater than 1,000, return. Okay, we'll start there. If after spawning, well, the blood pixels get removed, so there will be more spawned, but we want a potentially hard limit on the number of blood pixels on screen at any given point. Yeah, exactly. That's exactly what I expect to happen. And we want to examine how this looks, because it might be acceptable. It might not. But if the blood pixels are being generated in the right locations by the right entities, then it may not matter if we turn off spawning anymore until the others are taken care of. So instead of it being in, um, so we do 1,000 minus n. So that won't actually generate anything if we have it set up to 4,000. And the reason I'm trying to do it this way is I don't want to have an if statement inside the loop. If possible, we want to avoid any additional branches. Let's we're going to have a const int hard limit equals 1,000 hard limit. So the assumption here is that n is always going to be less than hard limit. In this case, it won't be, so nothing will get spawned. But let's turn down our blood pixel count to like 100. So naturally, oh, that doesn't look right. That's too many. Yeah, that's like 1,000. Wait. Oh wait, that math is wrong. I'm retarded. Hold on. That's how you know it's getting to be time to take a break soon. No, it's not hard limit minus n. It's not running slow if there are less bud pixels. I did a incorrect math thing here that I'm fixing. Give me one moment. Because let's say there's 500 on the screen and we want to spawn another 100. All right, let's just go ahead and do it with the if statement and just deal with optimizing it afterwards. So if entity size, not entity size, but if is blood pixel dot size greater than hard limit, then we return. Actually, we'll just break. All right. So this is standard behavior. Actually, we'll change it to like 500 or something like that. Naturally, with this current value set, it doesn't look all that fantastic. But it works. Well, you know, that's a nice thing about the component system, Raj, is that anytime I realize that there's a physics component that I can add and process during my update loop, I can create a new map to represent that component and map the entity ID to whatever value it is that I'm wanting to store. So it is totally possible to add such a component. instead, so what I would do to like do something like that is when I spawn the blood pixels to like make them rain down, for instance, that would actually be a really cool idea. Um, let's add that to the to-do. So really, the big computational expense at the moment is just having a hard limit on how many entities can actually be on the screen. Yeah, if I wasn't doing all of the movements using doubles, one of the big problems with that kind of setup is that I no longer get like the giant range of motion um, that I get by having the VX and VUI be actual doubles as opposed to like integers. You know, I don't know what the motivation of the skull is yet, to be honest. But part of me feels like he's kind of like the Grim Reaper as a floating head. He's not really out to save anyone so much as just collect souls. And it's always a quest to get the next biggest, better soul. And it's an infinite quest that never ends until you die. But that brings up an interesting question. How can the Grim Reaper die? Mm. Pumpkins. Oh, pumpkins. That's a great idea, Raj. Thank you. You've had two really good ideas. You've been a very great first new chatter. I want to thank you for joining and contributing. Mayhem. That's who's on my YouTube right now. I need to start getting ready for bed here. Okay, one thing that we can do I apologize for QBQBQDBQ. He's not very much an honest chatter at times. More often than not, they're just trying to create and have fun. We had this at like 20 earlier. I don't know if the hiccups at times are because I'm like streaming at the same time, or if it's like an actual choke point in the game. I think it's because I'm streaming. Yeah, no, I totally exist for your amusement. You know, this is totally not a serious thing that I'm trying to do here. So, you know. I forget that the only fun that I'm allowed to have is, I don't know. What fun am I allowed to have? Why don't you tell me? Because I'm having fun. Now, why we might have put a hard cap on the number of blood pixels that get created. Um, this doesn't put a cap on the number of entities on screen, and so it's very possible that there's still more slowdowns to discover. But the nice thing about this system is it's in a really good position. Like, there's no real crashes to speak of. Uh, Nothing that I've been able to get to crash in a while, anyway. We did fix a massive bug, though. But it didn't fix the slowdown issue. For a while, I thought it was crazy, but accessing a map adds to it. And from what I can see, it looked like I managed to fix that problem. So the sprite position itself is a an integer. X the what you see displayed here where it says player position, that's being pulled from the player transform, I believe. And I also noticed that the soul shard magnetism is no longer working. Here, I'll show you components. See, the sprite component here has a STL rect for the source and the destination, whereas the transform component uses a double. Now, I could actually consider changing this to an integer xy, but having played around with the velocity enough, we're going to want to keep the velocity as a double. It's very possible that just changing the double here to integer would actually have a big performance boost. But I'm going to have to be careful to go back through and change any instances where we're modifying a transform component and make sure that they're all integers. Because then there would be at least a factor of 1 in terms of less computational work that would have to be done when converting from one type to another. That's definitely something to consider. But before I forget, but this is okay. This is all okay. That's why that doesn't go there. Okay, that should fix that. Yeah, okay, that fixed that. Yeah, but it's not really that much of a memory optimization. Realistically, I could actually swap out the doubles with longs and still get the same performance boost. The reason being is that floating point computation is much slower than integer computation. And since longs actually use the same amount of memory as doubles, like if I were to swap one out for the other, like we'd still be using the same amount of memory, but we would still get the same performance boost. And in the end, like I've actually done a little bit of the look at the memory while the game is running. And even with tons of entities on the screen, we're barely cracking like 250 megabytes in RAM. So we could probably try to aim for lower, for sure. But with how fast everything renders and moves at the moment, some optimizations may not be worth it. May not be worth the time investment. And because this is a work in progress, I want to be able to balance attention to detail with actually creating new features and assets and elements that will be a part of the game. Because, yeah, getting the performance optimization is one aspect. Because, yeah, we do want to be able to handle lots of different things on the screen. Now, one thing that we'd be able to consider is finding a way to eliminate constantly checking the size of is blood pixel. Because we're doing that on every frame. Like, every time we spawn blood pixels, we have to check to see how many there are. And that can be expensive. So there's lots of little things like that that I have to go through and really fine tune in order to make for the best feeling experience. Boom. Whoops. Uh-oh. Now it's definitely broken. I forgot to turn on cleanup data structures. That was kind of funny. All right, let's die and make sure that that works. Okay. I think I've changed enough here today. How long have I been on? There's a lot to clean up here. Fuck. Oh, I haven't even been on 2 hours yet. But I guess it's a good time to take a break, though. Let's add everything. All right. I want to thank y'all for joining. We've got a lot more work to do, but things are cooking. Things feel good. Things look and operate reasonably well. We have some hard limits that we need to find a way to smooth over and work around or overcome or deal with. And I can't really ask for anything more. One step at a time, one step at a time. So we have a hard blood pixel limit at the moment, but we're going to figure out a way to overcome this. We have a hard number of entities on the screen that we can deal with at any given time before we start to experience lag. It shouldn't be too bad. But one thing at a time. Until next time. Evil Dojo 666.